All right, I was going to intro this, but what comes up says it all.
All right, thank you guys for coming. This is Build Your Own UAV 2.0, wireless mayhems from the heaven. My name's Michael Weigand. I'm from the United States Military Academy West Point, and I'm with...
I'm RenderMan. I'm just a nice guy, so I don't have quite the title he does, but... What, you don't believe me?
Hey, so we want to keep the energy up today. So let's show a little intro movie. Render, what time were we up last night?
I think we finally got things going at about just after midnight.
After midnight?
Yeah.
And where were we?
We were just up the strip at the Hilton Grand Great whatever resorts that was there. More correctly, the parkade that's right across there. About the 13th floor of said parkade. Yeah, there's no cameras up there, by the way. And so after these guys spending a great deal of time and energy trying to get the plane up and running, some unforeseen technical difficulties got in the way. We had to do our proof of concept of something. So, yeah, basically my iPhone went for a flight. So, as you'll see by the video, it was a very interesting flight.
So let's go ahead and roll this tape here. Are we rolling? Oh, I think we're minimized.
You're gonna need audio on the laptop.
Some audio? Oh, there we go.
This was last night, about 12:30, down the strip.
And this is where it gets a little hairy. I think it's because we were, playing Peep and Tom, and the gods were coming after us. So, right about here, we must have pissed somebody off.
Stabilizer motion. Stabilizer motion. Autopilot. Stall. Altitude.
There's a reason you don't see a plane on the stage right now. But, my phone went for about a 400-foot free fall inside of the styrofoam plane, so,
Now, we did recover. We'll show you the damage a little later on, but, all right, let's get back to business. Real quick. I mean, the slide speaks for itself. Also, Render, you have a service announcement to make, right?
I do?
Yes. The Fs, the three Fs.
Yeah. Anybody who's here from the FAA, FCC, or Apple warranty departments, please identify yourselves. If security could escort them. Nobody? Okay.
If you are in the crowd, and you must be out there, we are not answering your questions. Okay, so real quick, let's do a little technology overview. UAVs, we've all heard about them. What are they? All right, so UAVs, unmanned aerial vehicles. We know they're pilotless aircraft, right? We've all heard of the Predator drone, in combat war zones and everything. But what makes a UAV versus an autonomous UAV, et cetera? So autonomous, we all know autonomous means it's a self-governing vehicle. It has no pilot, no human interaction whatsoever. Unmanned aerial vehicle doesn't necessarily mean that a plane's autonomous. It just means that there's not, a human being up there. So no pilot necessary per se in the airframe. Predator drones, for example, can be remotely piloted, or they can be set, to basically run an autopilot, much like, and I guess this is kind of scary, any plane that you flew on to get over here. Chances are your pilot just took off, hit that red button, and put his feet up on the dash, and started
Putting that back
reading the
on the
paper.
off switch.
Yeah. Gotta watch that red button there. But But yeah, so most vehicles, most planes these days are capable of autopilot features. But what makes a unmanned aerial vehicle autonomous is that it doesn't require any human interaction for the entire duration of the flight. It has higher level intelligence. It can predict weather patterns, alter its flight plan according to numerous criteria. It can make decisions like a human being can. An autopilot, as you can imagine, simply just flies a pre-programmed route. Now these UAV systems, they range from medium to large scale systems, and what we're going to show you today are basically what you can do if you have $1,500, $2,000, you want to go out, spend some time, experience some heartbreak like we did last night, and build your own system.
Yeah, so it was more the abject terror when we were seeing blinking police car lights in the distance.
The plane hits the ground, and sure enough, whoop whoop, and they're right down the street. We're like, should we go get this or? Render, did you wipe your prints?
Yeah. I forgot about that part.
Okay, so if you guys were interested in going out in the market, now doggone my slides keep breaking, and you wanted to build your own system, more down at the DIY level, there are a whole series of complete autopilot solutions for model airplanes. All the way down at the bottom is the ArduPilot project. That's probably the cheapest one that I've come across yet. The original board was $25. Now, it's just a microcontroller. It's just an Arduino that's been modified for UAV purposes. And honestly, that's more than enough to get a plane to fly autonomously, or pseudo-autonomously. You still have to take off and land. But you give control over to it, and it flies basically whatever you program in. Now they've since graduated to an Arduino Mega that they've modified for purposes, and I guess kind of not too creatively called their new board ArduPilot Mega, but there's some other boards out there as well. The UAV Dev board, the Paparazzi project, that's an open source Linux-based autopilot project. FlexiPilot, Easy UAV. Getting more into the more expensive commercial products for small-scale models, we have Autopilot, and then you see up in the red, those are systems that cost over $1,500, and frankly are kind of out of my student budget, so I didn't really focus on those much. But the point is that if you have a little bit of change and you have the interest, there's a whole bunch of ready-made solutions out there that you can integrate into airframes. So continuing on with our UAV tech demo, basic flight characteristics. So an unmanned aerial vehicle is a plane, essentially. They can also be helicopters. They can be, I don't know what else there is, but I've seen some crazy stuff. I've even seen a flying lawnmower. Take it for what it's worth, but all UAVs share a couple things in common. They all have to fly, they all have to navigate, and they all operate some type of payload. So flight, we know any type of flying body is affected by four forces up in the air. You've got lift, weight or gravity, thrust, and drag affecting that body that's moving through air, which essentially is just a fluid. And so when we're flying, we have to both stabilize the platform, and we also have to take into account airspeed, and maintain some semblance of altitude, unlike what we did last night. Yeah. So once we have the flying piece and the plane's actually in the air, then we need to somehow control it. We want to give it direction because we want it to go where we want it to go. So that's where the navigation piece comes in handy. And we'll talk in a moment about the different components that make this really easy and cheap to perform. And then third, putting a UAV up in the air. All right, that's cool. We now have this object that can fly around wherever we want it, but what if we want it to do something? Now, I'm sure many of you out there can think of all kinds of creative applications for a plane that can fly by itself, but we want to operate some type of payload, so maybe we want to do some sensing missions like we were last night, checking out who left their blinds open on the Vegas Strip. Or, hey, maybe we want to do some sniffing operations. We want to, I want to follow RenderMan as he, sees all the sites around Vegas, and he just happened to leave his iPhone 802.11 on. Uh-oh. Maybe we want to send some live video back like we were doing using RF. shoot, maybe we want to put a laser up there. And I'm sure you guys can think of all kinds of other applications. We'll actually talk about some more payloads a little later on. Okay, so stabilization. This is traditionally one of the more difficult aspects of flying in general, but fortunately, because of the state of the industry, common off-the-shelf parts, COTS, they have the price for these components has dramatically dropped. There's essentially two very simple, easy, and inexpensive ways to stabilize any type of model airframe. The first is the thermopile sensor approach. This essentially is a two-axis thermopile sensor board, which senses the infrared difference between the sky and the ground. I'll show you next slide. They're really easy to use. They're extremely cheap, 40 to 60 bucks, and in almost all weather conditions and terrain environments, they're more than enough. Now, given they don't work so well in blizzards or in very dense fog, in mountainous urban terrain like we are here in Vegas, but for your average application, it's more than enough. And then the other method is the inertial measurement unit. Essentially, you're taking three accelerometers or gyroscopes, and each one of them is on axes with one of the three planes. And then using some calculations and math, we can essentially sense every change to that airframe as it moves in three-dimensional space. And so that way we have a pretty good idea of its current orientation. These systems are becoming cheap. They're more complex and a little bit difficult to work with, but at the moment there are autopilots that are using just IMUs that are relatively inexpensive, and we can continue to see this drop in the next couple months specifically. So the thermopile-based approach. This is my favorite because, again, it's the cheapest. Hey, anything that's cheap is good with me. And also, for me, so far it's been the most fail-safe.
Yeah, except for when you don't have hot glue.
That's when it falls off the airframe and it's dangling in the slipstream, it doesn't work so well. Go figure. But usually, we just put this little black box. This is an FMA Copilot 4 sensor. It's, I think, 60 bucks or 70 bucks from FMA Direct. And we were supposed to hot glue this to the top. But we didn't have any hot glue, and we got a little excited, so we figured double-sided sticky tape from CVS would be enough.
So it falls off, and it's seeing the horizon do this and everything, and the autopilot's doing exactly what it was supposed to and trying to keep it level. Unfortunately, when the horizon's doing this, that's kind of hard, and gravity is a harsh mistress.
I submit that it was actually keeping it level to what it was sensing, but
just so you know, I'll know, we tested it. Gravity still works. It's still good.
Yeah. And the iPhone survives.
Amazingly.
So you guys can kind of see one sensor will face the ground when the wings are tilted left, right, or forward, backward, and the other sensor will see more of the sky. The sky in the infrared spectrum is always colder than the ground, even when it's covered with snow and ice like it normally is in northern New York, where I'm holed up most of the year. So we know that in almost all weather conditions this works pretty nicely. This gives us a horizon sensing capability. It's very easy to work with, writing your own custom code. Because it gives you a nice little even distribution like you see in the bottom. And we essentially just want to minimize the error between the opposite sensors in two axes. And so we just give out control outputs to the elevator, which is going to make it go up and down, nose up and down, or to our ailerons or rudder, depending on our airplane configuration, which is going to make it tilt left and right, like you see our fighter jet here. So very simple. Servos. So the airplane, the whole servos are relatively simple to many of you, but I actually found these a little complicated when I got started. Servos have become pretty advanced in recent years. For 12 or 13 bucks, you can get this HS55. It's a extremely small, extremely lightweight servo that is able to swing its arm to a very specific direction, given a PWM or pulse width modulated signal. So on the bottom left, you see, with a minimum pulse, a neutral pulse, or maximum pulse, it'll swing the arm to a given direction. It provides a lot of torque, very fast response time, and they're very reliable. Did I mention they're really inexpensive? So as you can see, the servo, it's essentially just a motor, and it has a potentiometer and a control circuit on there. You just feed it 5 volts and in the signal, the PWM signal, and it's good to go. The servos are what we use to control all the control surfaces on the plane. The ailerons, the rudder, the elevator. when you're flying home, you know, if you get one of those awesome window seats, I'm a fan of window seats, and you look out to the left and you kind of see, you know, that aileron going, you know, left, right, trying to keep the plane flat. Well, essentially,
I love how you say trying.
Trying. It probably
Better
is
if I'm
working
sitting in
better
that
for you.
seat.
Boeing does a little bit better job of this than I do, but
They don't use hot glue.
epoxy, right? So the servos just let us move all our control surfaces. All right, then autopilot systems. So I mentioned that there's a whole range of autopilot systems. Some of my favorites, though, are the microcontroller-based systems like the ArduPilot Mega board you see right there. It's actually sold by SparkFun.com for 50 or 60 bucks right now. It doesn't include all the pins, and once you add some of the other sensors that you need, it comes out to about $200. But that very small board right there is literally all you need. It's just a modified Arduino Mega. The Paparazzi project I'm a serious fan of because all the source code, much like the ArduPilot project, is completely open source, but they've been around a little bit longer, so I feel like their sources, it's better developed, it's far better commented, and the Paparazzi will work on Linux operating system, which I'm a fan of, because anytime you can make the plane run on Linux, I mean, take it for what it's worth.
Unleash the flying penguins.
There you go. Penguins do fly, I promise. So future work, the Beagle board in the bottom right is a $150 Pentium 3 equivalent computer that fits in your hand. This is one right here. It's just a single board computer. Runs any Linux distribution that you flash to an SD card, and it has, I think it runs at 750 something megahertz, so it's got plenty of processing power, USB connectivity. It's beautiful. So future work is taking the Beagle board and maybe developing our own autopilot framework right on it, just because we can. Telemetry. So it's really nice now that we have the plane is actually flying, it's stabilized. We have the autopilot that's given it some intelligence. It can, you know, fly waypoints and whatnot with the hardware that we just saw. But what if we actually want to interact with it? We want to see what it's doing. We want to see its current airspeed, altitude, next waypoint. Maybe we want to push data to it, you know, reroute its flight plan, etc. So we need a way to communicate with it. XBs and Zigbees have been on the market now for a couple years. They're a 802.14.5 system, and they work beautifully. They're essentially a wireless serial link. They're very easy to program with Digi's XCTU program, and with the 900 megahertz EXE modems, you can get out to a 12, maybe 15-mile range, depending on your antenna setup and whatnot. And
Line of sight, a few other things.
yeah, line of sight is usually helpful, but with the RPSMA connectors on the end, we can essentially plug any antenna that we like in this, so we can really beam traffic out pretty far. So we know that we can touch it, and in many cases we can reach back pretty reliably. Cellular is actually really becoming popular in the DIY drones community because it's a higher bandwidth, easier way to network your UAV up in the air. So say we put our Beagle board on the plane, we just plug in one of these, you know, relatively inexpensive USB cellular devices, you know, pick your vendor, Verizon, T-Mobile, AT&T, and now we have our Beagle board on, you know, the internet. Now, I'm sure you guys can imagine what we can do with that, but if we have a plane flying in the air and it's networked, then we have unlimited range as long as we're within the cell network. And hey, now I can play with this across the planet too. I don't necessarily have to be in the same state. So that's pretty easy. The video feed. Unfortunately, our video feed was a little shoddy. That's because I was using my $30 camera and not my actually better $18 camera. But in the upper left-hand corner, you see a board camera. These are really inexpensive CCD board cameras. They're awesome. I mean, they see near IR. You saw a night flight. That's not some night vision system. That is a board camera. I mean, no joke, $30. It doesn't get better than that, really. So
Not without a whole lot more money.
yeah. Now you give me a lot of money, I'm sure we could do better, but yeah. But then, there's a whole selection of transmitters out there. If you have your ham radio license, then you have more band privileges, and there's all kinds of stuff you can do. I've got a ham radio license. I encourage many of you to get it as well, if for no other reason than because you get the band privileges. But using the ham radio bands, we can push video feed out pretty much as far as we can go. You have a lot of band privileges, and you can roll your own system. So what I'd like to learn to do sometime soon is I want to roll my own 434 megahertz video system and see just how far I can push out a reliable video feed. Because as you saw, it kind of gets a little bit fuzzy. Right now on the ground we're using a directional antenna. It's spotty, to be honest. GPS. So the plane, obviously knowing its current location, that's kind of an important feature. Many of our phones now have GPS receivers, so you can only imagine how small they are. What you see here are actually really high-end GPS devices that literally fit in the palm of your hand. They're about the size of a quarter each. A 10 hertz refresh rate down to, on average, 2 to 3 meter resolution. GPS receiver is only going to cost you about $80, so that's freaking awesome. In airframe. All right, so now we have all these devices. We can get our plane up in the air. So what do we put them in? Well, I recommend a foam model. Go out there, go online, and find a foam model airplane, and modify it.
It makes a really good iPhone case.
It does. It will protect the iPhone. No promise.
At least from 400 feet.
Brendan, do you want to talk about some of the benefits of foam?
Definitely. Having seen this thing in action for the first time last night, I've seen all sorts of videos and pictures and stuff. It's light, it's cheap, damn near disposable. So, we plowed this thing into an RV park, into the parking lot.
And 25 miles an hour.
Yeah, 25 miles an hour. And yeah, it's pretty trashed, but a bit of glue, some tape, you can put it back together. But also, for the most part, if you plan your installation of all the electronics correctly or sanely, you could basically, airframe's trashed, another $80, $100, get another one, just transplant everything, and you're good to go again. So you could afford to be a little bit stupid with the thing. It's going to cost you a little bit, but not, the $20,000 that some of the real professionals.
I'd say double-sided tape cost us about $100 last night, didn't it?
About, what's your time worth, too? You got to include that.
Not much, so it's all right. Some community-proven airframes. If you guys go online, there's a large DIY UAV community. It's at DIYdrones.com and also rcgroups.com. There's a really active, make-it-yourself UAV community there. A lot of people have agreed that these two airframes here, the Easy Star on the left and this unknown manufacturer Skywalker on the right, are some awesome airframes. Last night we were flying with the Skywalker. This thing's $100. You kind of buy it on eBay or through some shady reseller, and it comes from China in a nice little crumpled box, but it's all good. I mean, it works. And the models, they carry a lot of weight. Again, they weigh nothing. They're practically disposable. So as long as you can retrieve it at the end of the day and pull your electronics out, you can be up and flying again in a couple hours. And actually, one of the best things about foam is that we can repair these. Say, literally, the wing snaps in half. I think we have some videos of it should have happened had it not been a foam model. But you just take some Gorilla Glue, that you get from Home Depot, and some water, and you let the foam, let the glue foam up a little bit, and then adhere that foam together. And the glue connection is stronger than the foam itself. So from any amount of damage, and I'm speaking from personal experience, you can glue and tape an airplane back together and somehow get it up in the sky. So let's show a real quick build log of what I do when I get my new Easy Star. So I get the Easy Star, I pull it out of the box, and this is the foam fuselage that I see. It splits in half just like this, and you can see all the interior space and whatnot. I upgrade the motor. I don't use any of the stock components. This is a brushless motor that runs at about 14,000 RPM at normal voltage. It's spinning a 7-inch prop and actually provides an enormous amount of thrust, so much that even when the plane is fully loaded, we can accelerate almost vertically. And also in the bottom there, you see this that device that says 36. That's an ESC, or an electronic speed controller. That essentially is what our battery plugs into, and essentially is like a throttle for our motor. It also provides power to the receiver and to our other electronics on the plane. So I make some incisions and kind of route this through, and a lot of hot glue to kind of keep everything put in there, and then I throw the receiver in, which is that other box that you see. Start connecting up the wires. I didn't show, there's an outside photo. The servos literally slide in the side, and we connect the push rods and everything that control the servo arms to the control surfaces. And at that point, we're pretty much ready to go. We just have to drop a payload in. So we do that. Payload, bingo. Camera, pan tilt mount under wing, so it won't get ripped off when it crash. And we're finished. I mean, too easy. And you see that black box on top? That time, it was hot glued on. And that suspicious looking antenna out the front, that is the video transmitter, but I mean, who knows what it really could be, so. All right, movie time. Let's show some movies.
Show one of the more successful ones.
One of the more successful ones? Okay. So this is over somewhere in Southern California. Just ignore those lights that you see in the sky. That's not air traffic or anything. And so when we have the plane stabilized and the autopilot turned on, it just gives it rudimentary, left and right control basically. The stabilization system just keeps it flat level, and we just kind of fly a route. The camera you see panning and tilting according to the ground user. He's wearing a gyroscope attached to a helmet or a hat, and he's wearing video goggles. So it's like he's sitting in the plane. It's a really cool sensation. It's made a couple people sick. It's made a couple people fall over. I got thrown up on once. And basically, wherever you look, it's like you're sitting in this little foam plane, and the camera looks, and you're there.
Just little dots in the sky.
Stars.
Yeah, that's it.
Moving stars.
Stars.
In line.
Nice sequential line.
So this is Southern California from the sky at night. And again, remember, this is just a $30 board camera. The CCD lenses, or the CCD imagers, actually see near IR. So especially when there's all this light pollution, from street lights and buildings lit up, I mean, we can see very nicely in the dark.
Yeah, that's you guys down there, I think.
Yeah, I think we were trying to wave at some point.
Yeah, but you can see the vehicles, you can see those people. That's a pretty decent amount of...
Let's fast forward a little. Coming in for landing. Actually, I wonder, is this our interesting movie? Yes, it says.
Yeah.
Okay. We thought it'd be really cool if we flew between some buildings.
You see the trees in the courtyard.
And then my friend's like, hey, look, a traffic cone. So we decided, we're going to bring it back. We were actually having problems initially with our electronic speed controller was overheating, and it happens to just cut the motor out at some point, which is not really behavior that we want to see when we're up in the air, and we don't have any idea it's happening.
Yeah.
So we decided, we'd kind of bring it back. Render, can you point out that building in the bottom right?
Yeah, this building here.
That building right there, yeah.
Yeah.
Okay, we'll talk about that in just a second. Yep. Wait for it. Wait for it. I'm actually going to turn the sound on so we can hear something kind of unique here. Oh, there it goes.
No motor.
And back again. That, ladies and gentlemen, is the sound of UAV death. So that... So that building that we saw there, that was the LA Clippers main office and training facility. Now my friends and I, we get in the car, we go drive over there, we're like, all right, we think the plane's around here somewhere. So it's still transmitting video at this point. We have no way to remotely turn it off. So, we get out of the car, we got this giant patch antenna, and we're doing this the whole time. I think it's over here, man. Nope, right. So anyways, we walk around this building back and forth, back and forth. At some point, one of my friends is like, dude, it's on the building. No, it's not on the building. Okay, well, let's get on the building. So we go over to, to the front door, and it's actually got some pretty impressive security. We noticed as we walked around, there's about 5 cameras on every side. We were like, did you get, like, who works here, So we walked to the front door, and we're like, oh, shoot, LA Clippers. That's a basketball team, right? So we're like, all right, well, they got to have night security. So we go up to the front door. There's all these things, and we're looking at this. We're trying to figure out like how to press the doorbell. And there's this giant thing, and we open it up, and
Can you just imagine like a half a dozen geeks standing there trying to figure out how to operate a doorbell? Wish I could have been there.
this was bad. Well, we figured out there isn't actually a doorbell. There's a fingerprint scanner, though. And we were like, whoa, dude, cameras, fingerprint scanner. And then as soon as we did that, this giant light like just beams up, and we couldn't see anything. And then we noticed, oh my God, that's a camera. Facial recognition. I'm not kidding, guys. I asked them about it the next morning. So we were like, all right, we're out of here. We're not climbing, we're not scaling this building, not with all this. And so the next morning I come back, and they just opened up, and I'm walking in next to some giant basketball player. It's like twice my size. I was like, hi. He's like, hello, little man. What are you doing? I'm just here to see the secretary. Okay, she's over here. So some basketball player, walks me to the front desk, and this lady, she's typing away at her computer, and she looks up. She's like, hi, can I help you? I'm like, yeah. I'm from the Army, and I lost...
You see, the best I can ever use is I'm from the internet, and that just doesn't have the same clout, so...
Yeah, so we lost this experimental drone on your roof last night. Oh my God. You would not believe the week I'm having. We're trying to get Kobe to come here, and I don't think it's going to work out. So I am so not surprised this drone landed on the roof. What's a drone?
I'd just like to point out, I have an empty cup here.
Oh, the man in the front with the flask. Well done, sir.
This is what I think it is. 1928 Bolshevik vodka.
I'm not going to get a security clearance after this.
You expected one?
So they let me up on the roof. We get the plane back. The batteries were, were dead. Yeah, thank you, sir. And, we got it back. We actually had it up in the air the next day, and this is the footage that we took. If you can see, but is it really that
Tastes
bad?
like revolution.
Well done, sir. So, I just want to point out again, with a $30 camera, we can see shrubbery individually. We can, and again, this is up high enough that you can't see it, unless you're really looking for it, but you certainly can't hear it. And I think there was a soccer game going on. We were trying to count how many people were playing on the either side. You might be able to see it. It should be right in the center of the screen next to that seashell thing that's in the middle. We were checking that out, too. Turned out to be a bandstand. Who knew? Seashell, bandstand. But yeah, so this is about typical. So let's cut this back to the slideshow. Okay. Render, what happened there? I thought we took this off.
I thought so too, but I guess we should address it anyways.
Okay, so so some of you know this, many of you don't. I'm currently working at DARPA for Mudge. Everybody clap it up for Mudge, thank you. I'm so ignorant. I actually didn't know who Mudge was until I showed up there. And I'm sorry, I'm very young. All right. And like,
Oh, okay.
I'm gonna pull the age card on that. But he sits me down at his office the first day, and he's got all these locks on his desk, and I'm like, whoa. All right, really? So I sit down, he just folds his hands across his desk and doesn't say anything. And there's this person in the corner that's just scribbling notes. Just looking down, scribbling notes, looks up, gives me the stinky eye, looks down. I'm like, wow, this is kind of creepy. So he just kind of, motions to the locks, and I take the hint, all right, lock picking. Thank God I learned this at Tool. And so I cracked a couple locks, and then we start talking. Well, a couple days later, we were doing the same thing again. We're talking in his office, and I was telling him about my UAV, and we were just brainstorming like crazy ideas. And I was like, man, I wonder how much it'd cost to put like a rocket on my plane. He's like, you know what? Why are you still here? I'm like, what do you mean? He's like, I don't want to see your face again until I see a rocket on this plane. It's like, get out of here. Like, come back with some footage. Don't do anything stupid.
For varying degrees of stupid,
There are varying degrees of stupidity. So here's our candid shot. You see on the left we've got a camera, on the right we've got a missile. What does this look like, right?
And at this point, I'm getting an email afterwards saying, dude, I strapped a rocket to the thing. And I'm like, do I still want to be involved in this?
Audio, yes. All right, so I'm going to show you a couple different tries here, because this did take a couple. Fast forward real quick. Yeah, try shooting that down. Bring it, FBI. Okay, I think we're rolling around here. So, as you can see, try one didn't go so well. It actually got stuck on the rail system. So who knew that just, bent aluminum rods, it doesn't work so well when the angles aren't right. So we covered the plane, put it up again. This is try two. Try two is a little more interesting. Come on, baby. Turn her around. Nice and slow. Line up. Line up on target. Ready? Target. Stay on target. Yeah! Get some! Get some! And try three is much of the same, but doggone, do I have yeah, let's go back to the slides real quick. We'll show you the damage. The damage done. A little bit significant. Unintentional, of course. Going back, okay. F5. Oh, come on, dude. Really, Gates, really? Okay, the candid movie. Damage. I'll let you read this real quick.
Not that any of you have ever seen that particular setting on a fire extinguisher.
So, I think it was in my third or fourth go, because I was really getting into this at this point. I decided, man, it'd be really cool, if I could do some chaff, I could spoof another rocket and whatnot. Maybe, they're coming in to get me, and chaff, spoofed your rocket, man. And so I went into the kitchen, and I'm looking around all right, aluminum foil, okay, scissors. So I cut up all these little tiny balls of aluminum, and I pack them in this Estes rocket, and I thought, all right, this is going to be cool. So I launched this, and, I don't really...
Good ideas have started like that. This seems like that should be cool.
So if any of you are from the show of hands from the East Coast. East Coast and head down. All right. Woo! East Coast. So it's been really hot in the East Coast, much like Vegas. We're not used to it. Turns out all the grass is dead, and turns out the hayfield itself is dry. Oh my God! So we fire this rocket. I fire this rocket. Sorry. I'm not going to put this off on you.
No, that's all your problem.
Into a hayfield, and who knew that the aluminum would be like burning embers as it came out of the rocket? Not quite what I envisioned. So yeah, that's how that went down.
So my involvement in this was purely by email and some phone conversations. No, I'm in northern Canada. I'm in 2,000 miles away, and he's hanging out at the West Point, not a place that I could just wander onto.
Just throw me off under the bus, man. Really?
No, I'm just talking about the logistics of things is a little hard. But as soon as I saw this, I'm like, first thing I'm thinking, we need to get Kismet running on this thing. We need to do some wireless sniffing with this thing. So, but I started thinking beyond that. I'm like, okay, so we got a wireless sniffer. What do we do with it? Yeah, warflying's been done, but we got something with GPS that can move on its own. We're getting signal data from a device. Basically, you can put all that together and you start looking at things like the Beagle board that's like a Pentium 3. It's got enough brains. You can start feeding all of this in, and like you were saying earlier, if you had an iPhone that's sitting there beaconing, you could track that. And basically, by the strongest signal, each GPS location, just have it circle that, do samples, and just like hover over somebody as they're walking through the courtyard or something. I think that's kind of cool. It's also a little terrifying. But there's other things like, all right, well, strap an AP to this thing, have it do de-auth attacks, fly it over place, put in something like AirDrop and just drop Apple devices or whatever. But again, it's like that's just annoyance kind of stuff. I started thinking about this more, and there's things like OpenBTS, they basically like open source like cell tower that you could do with this. You could use this thing as a communications relay, and this has the major advantage over like a model helicopter that it deals with the wind. It's self-stabilizing. You just have this thing doing a circular pattern over where you are, and you've got a communications relay. Whatever frequencies you want to use, whatever system. You could do this. So you open mesh if you want to get network up and over a hill. Place the infrared camera with forward-looking infrared. You've now got something that search and rescue would love to have. And I actually had a few messages exchanged with Noid, one of the security guys, whose day job is search and rescue. And he was giving me all sorts of stuff they'd love this thing to do. Beacon, the safety beacon tracking and stuff like that. That there's no reason that we're already a $1,500, $2,000 budget, give or take.
Yeah, that's disposable, right?
And that's just for like the base station, all the radios and everything. After that, your new airframe is like $100. So search and rescue, to have something like this, they can just fire up to get a mile or two ahead of them to get some video back as to what's going on. There's some serious utility in that. One of the other things I was looking at was the strapping like a high-res still camera. Like these guys are doing the curvature of the earth shots with the balloons, with the CHDK hacked Canon cameras. Strap something like that into the camera, have it pointing down. If you're flying over a disaster, you could get damn near real-time, high-res images of what's going on. Bring that back, slap the SD card in. You now have, stitch it all together. You've now got basically aerial reconnaissance of your situation. I mean, even a more pedestrian thing is if you're trying to sell a piece of land or something like that, you want to show how big it is or what the terrain is like, throw something like this up and you can take pictures and do all that. It's well within the realm of the everyman. I can honestly say that, like, how many of you are familiar with Sahana? It's an open source disaster relief package that was after the tsunamis in Southeast Asia. Basically, it's for tracking, who's where, allocation of resources, all sorts of stuff. Something like this, where you could put in real-time imagery of places you haven't gotten to yet, so that guys who are going there know what's coming up over that next hill. That's insanely useful. There's wonderful stories by the OpenStreetMap guys when the earthquake in Haiti, where they didn't have good maps of Port-au-Prince. So Google and everybody else released all their satellite imagery for free to these guys. They put it out, crowdsourced it, where people could basically take this satellite imagery, trace out the streets, get some expatriates that knew, okay, that's this street name, and within a few days had a really good map that you could load onto like a Garmin GPS and go. because all these disaster people coming in had there's one main road, that's all their GPSs had. So the ability to have, for the normal cost of like $20,000 for a pro drone, to be able to do 20 of these things, cover a massive amount of space, give them to anybody who wants them. There's some serious things. So I'm going to be pursuing a bunch of these things over the next period of time here to try to see what can we strap to this thing and how can we make this thing useful.
So I'm not going to confirm nor deny that we may have put all kinds of really shady wireless stuff on a plane, and maybe we're working on stealing GSM traffic at the handshake using a plane. But let's show you some Vegas flight imagery. This was yesterday. That's just proving that the airframe is very flexible right there. This was last night. Yep, more last night. That's the disaster.
This is in an RV campground right beside the hotel that this thing came plowing down in, and all the locals came out and were like, what the hell is this thing?
But what I'd like to show you guys, so we flew RenderMan's iPhone last night, and what did we get with that?
172 access points in the, we were in there for 45 seconds or so. Originally, it was because they were trying to get this thing running, this Beagle board, with 3 sniffer dongles on it. But it was like a case of couldn't get it to work in the time, so it's like, all right, fire it up, strap it in, let's go.
We actually had a power issue. We couldn't supply enough amps to it because our 5-volt regulator was overheating and literally just, kind of messed up the bed pretty bad. So I just want to show you guys a real quick demo. This is our Beagle board with all kinds of nefarious things that we're neither going to confirm nor deny exist. Thank you very much, Mike Kershaw. And once this boots up, you'll see it just automatically goes into sniff zone. So you know how Google was rolling around doing their whole street view thing, and they were stealing Wi-Fi traffic? Well, now we're flying around doing the same. And not only that, but if your home network just happens to be WPA encrypted, well, it's not anymore. And there we go. So, yeah. If anybody has any devices on in the room, you are on screen. And so some other really interesting issues. Driver. That's not part of the demo. Some other really interesting things that we want to look into, especially concerning the search and rescue or for nefarious purposes, are actually radio direction finding to either cell phones or 802.11 devices. If you're some hikers, you get lost, search and rescue just puts a plane up.
Search beacons, they can say, okay, yeah, you're obviously not in this area or something. I mean, you got to think if there's a plane crash or something like that. I mean, yeah, firing a rocket's cool, but pretty much the same thing could be adapted to drop smoke so a rescue helicopter knows where to land. That's useful.
And also, we think that it'd be really cool if we could host our own cellular network on the fly wherever we happen to be. And quite literally on the fly when you think about it.
Because we'll talk to Chris Padgett afterwards.
Yeah, we really do need to get with him. But we'd like to take his system and put it on the plane because, again, imagine the Haitian disaster. What if all the comms are down, you just put a plane up and boom, you got a cell tower up in the sky. And it has persistence. So let's go ahead. We'll play some more
play some
movies
video
real quick.
And take some questions here.
Yeah, any questions? With that Chinese unknown manufacturer model, I'm guessing about 3 pounds is about as much as I put on there. If you put a larger engine on there, I mean, really, you could probably bump that up even more. But
it's just a matter of how much money do you want to dump into it. It's like the.
Say again? Flight time? Okay, so flight time's dependent on weather conditions, weight, configuration, and a whole mess of other issues. But right now, with really inexpensive lithium polymer cells and those high efficiency motors, you're looking at in excess of an hour, especially if you're just cruising.